We're going to be looking at problem 226, invert binary tree. So as per usual, the 3 steps to solving any problem are 1, understand it, 2, visualize it, and 3, implement. This is a really simple one to understand. Given the root of a binary tree, invert the tree and return its root. And the constraints are that, I guess there's going to be up to 100 nodes and as little as 0 nodes, and the value of each node is between negative 100 and 100. And here we have an example. So our root node is 4 and has 2 children because it's binary, 2 and 7. 7 and 2 flip, and then as we see that 7, its children were 6 and 9. Now they flip to 9 and 6 here, so 9, 6. And then for the other child that was 2, its children are 1 and 3, and then its children become 3 and 1. So this can be solved with a depth first search traversal. The main thing to do is just to know how to do basic tree manipulation. So let's just visualize this slightly closer, like what our strategy is. So let me just copy over our tree. Okay, so here we have the same tree as before, and this is the one we're gonna be messing around with. So okay, so the root stays the same no matter what. It's 4, and then its children 2 and 7 flip. So let's imagine what that looks like. So 7 has 6 and 9 as children, 2 has 1 and 3 as children. So let's do exactly that. 6 and 9, 1 and 3. So if we just flipped 2 and 7 once, this is what we would have. And obviously it's not quite the end result we want. 9, 6, 3, 1 versus 6, 9, 1, 3. Those need to flip 2. So let's flip 6 and 9. So basically we're doing the same process where for 4 we flip 2 and 7. Now for 7 we're going to flip 6 and 9, and for 2 we're going to flip 1 and 3. And there you have it. So in 2 steps we can invert the tree. And so now let's implement this. Let's do exactly what. Oh, and then let me first just add this base scenario where it's an empty node. I like to just return it as is in case I don't know if it comes back as null. Like let's just forget that question and move on. Like so, the first thing we did was we just flipped 2 and 7. So let's just do exactly that. And so I'm gonna create a temporary root.left because we're about to change root.left, so let's keep a in memory what its left was. So now we can say root.right equals temp. So in this case we flipped exactly 2 and 7, so let's just and we can even see that. So return. Look, if I copy this into a new tree, we'll see that for 7 and 2 flipped, but 6 and 9 and 1 and 3, those need to flip too. So how do we do this recursively? And this is where depth first search comes in. So let's do a pre-order traversal. So we're given a node. You can choose any form of traversal. I think they should all work the same. So if there's no node that we're passing in, let's just return. We'll just stop traversing. Just call it quits. And now we can just copy this over here. And now instead of root, we're passing in the node. And then we have to keep iterating. So you saw how we missed flipping the 9 and the 6, 3 and 1. Now let's make sure not to miss any children. And finally, let's just call this function down here with the root. And this should, let's see if it solves this solution. Yeah, it solved that one. Let's run the test cases. They're good. Let's submit it. And we're good. So thank you.